Okay, can everyone hear me? Yep. All right, let's start. So that was me 20 years ago, much better looking, probably more intelligent. But for my final year project, voila, I did a fingerprint recognition system. And whilst it was very interesting, it didn't really do what I wanted it to do. And the reason being, and I think Paul and a few others touched on it earlier, the guy from NVIDIA, we just didn't have the computational power. So for us to train our algorithm properly, it would have taken 2.5 years where our calculations were. So when I left college, I wanted to earn money, so I went working and didn't stay in research. But then I wanted to get back into data science, and I met Joe-Fai Chow at one of our IBM events. Just be careful with Joe. If you be friends with him, he will make you buy a 360 camera, and yes, I have a 360 camera, so just be careful of that. But one of the things which I talked to him about was, look, if you want to get back into data science, what can you do? You know, let's think of a really good demo that could show off the power of like IBM's products along with H2O products and maybe a couple other partner products. So has anyone ever heard of Moneyball? Okay, so I'm into sports. I'm also a Red Sox fan, which is good because they won the World Series. So we decided to look at the Moneyball problem. Few reasons. A lot of people would understand it. Again, it was primarily based on statistics. One of the opening gambits is how on-field first base percentage was what was being analyzed as opposed to who hit the most home runs or what certain statistics were. So we were like, okay, let's go and start that journey. So Joe's from Hong Kong, I'm from Ireland. Neither of those teams play a lot of baseball. Play a bit of cricket, but not much more. So we teamed up with Ari Kaplan. Now, unfortunately, Ari couldn't make this presentation, but Ari is Mr. Moneyball. So the Oakland Athletics is where Moneyball was based on. Michael Lewis wrote the book based on Billy Beane. But the guy who was the Jonah Hill character didn't want to have anything to do with the movie. So they said, okay, but we need to talk to someone who knows something. That was Ari Kaplan. So Ari has worked for over half the MLB teams. He set up the analytics department in the Chicago Cubs, and after 108 years, he had left them at this stage, they actually went and won the World Series and broke the curse of the GOAT. He was also involved with the Red Sox, and from there he helped recruit Theo Epstein from the Red Sox to the Chicago Cubs. So he's well versed. He is the subject matter expert of baseball. And what I hope you get from this, and I'll say it at the end, is a lot of sports teams have curses. You know, they believe it's because somebody brought a goat into a ball club and they wouldn't let him in, and others believe it's because somebody was having a party while a funeral was taking place. That's a Mayo curse. But ultimately, that's just folklore. It's data and analytics, as well as a good team, will help you get over the line. So what you will see today, if you went on to like MLB or ESPN, you'll see like a 1-year production. So for all the general stats, you'd go and you look at it and you'll see 1 year into the future. But generally, businesses don't run on looking 1 year into the future. If you're signing a contract of a player, you're looking 3 to 5 years. You want to see what is their performance going to be as they get older. And at two ends of the extremes, that's, you know, a young, unproven batter, and then maybe an older batter who's proven, but are they declining? You want to be able to see, you know, are they worth a 3-year contract? Are they worth a 5-year contract? What are they worth? And that is what the baseball clubs challenge themselves with today. So hopefully what you will find is everything's about the data, right? I think in all the keynote speeches, everyone talked about the importance of data, and this is absolutely no different. So when Joe and I started this, we looked at the layman database. So the URL's up there. Anybody can go and download this data set. But ultimately what it is, it's a data set based on over 100 years of baseball data. It's highly aggregated. So what that means is a pitcher or a batter will only have one entry in that database in the pitching table or the batting table. And it'll be their aggregated statistics for that whole year. But then when we started working with Ari, we actually got a Major League Baseball data set. We called it AriDB. So from about 2008, what they have now, the ball clubs get is a database. It's about 800,000 rows of data, and it's every single pitch that is thrown in that league. Okay, so you're going from a highly aggregated data set to an event type data set. And on that event type data set, there's a huge amount of information. So that's Chris Sale through the last pitch of the World Series, won it for the Red Sox. And what you're going to see here is some of the layman database. So it would be your standard kind of stats like game 1, number of hits given, number of home runs given up, ERA, general kind of stats that you would see. Okay, and that is in the layman database, and anybody can download that and have fun with it. Now what you kind of see here is Ari's database. So what you're getting now is, so think about, I know the number of home runs Chris Sale gave up, but do you know the height upon which he releases the ball at to feed off the ground? Do you know the number of spins that are on a given ball? Generally, the census is the higher the spin rate, the harder it is to hit. Do you know the change in his velocities? Do you know the number of actual pitches that he throws? And that is the data set that these baseball clubs are getting. Now, the ones who are doing better are the ones who are able to analyze this data and make predictions and analysis based off it, and then being able to communicate that to the players. So one of the things which I think it was talked about earlier on was how you present that picture to people, right? And people come in different disguises. So you might get someone who's highly analytic, a pitcher who's highly analytic, or a batter who's highly analytic. They love all those stats, they love the spray charts, they want to get everything they want to know about who they're facing, what they can do, what they can't do, and they can consume all that information. But then Ari worked with a batter who had an attention deficit disorder. So they had all the information, and they understood that when the ball was pitched low, he generally always struck out and literally couldn't really hit that ball. And what they wanted to say to him is, because sometimes a pitcher would purposely throw a low ball below the hitting zone, forcing the batter to strike. If he'd left it alone, it'd be a no ball. So this guy couldn't consume the information. So whilst the team had that amount of information, it was how they communicated to him. And it literally was, when it's low, let it go. It's the only thing that he could consume due to his attention deficit disorder. But the team that helped him to get to that level had all the analytics and knew what he shouldn't do. So what we did is we built an application, and it had to be at an enterprise scale. Okay, so we had a data center in Coppell in Texas, and what we had was we had two databases. We had Hortonworks and we had DB2 Warehouse. We put layman in DB2 Warehouse and we put Ari's into Hortonworks. Why? We wanted to work with two separate databases just to show it could work. Then what we had was Aginity Amp. And what Aginity Amp can do, it can suck in data from multiple sources, it can categorize them, and it can also do a thing called derived attributes. And that's another thing which I'm going to just touch on after this slide. What we also had was IBM DSX. I'm IBM, we love renaming things. It's now called Watson Studio. By the time I walk out the door, it may be called something else, I don't know. But the beauty of that is it can be shared across multiple individuals. We can all share the same notebooks. We can use open source technology. So we used OR, and we were able to use H2O. So we used H2O and we installed it into the OR environment. So very, very scalable, but also very, very easy to use. And the other aspect that we did is we used a thing called Immersive Insight. So we put an augmented reality demo on it. So when Joe and I presented this last March, we were able to present 3D diagrams that people with a Microsoft HoloLens could manipulate and investigate. So it was just another way of being able to visualize the data. So when we talked about the derived attributes, so what Ari did for us, so our subject matter expert, is he looked at that Major League Baseball, and from that data set, he derived some new features. Think about it as the feature engineering that's in driverless AI today. So instead of an algorithm doing it, we had Ari do it for us. So unless you were a baseball expert, you wouldn't know that one of the kind of clutch points is looking at fastballs above and below 93 miles an hour. Okay, generally, it's a lot harder to hit a fastball when it goes over 93. It's a little bit easier when it goes under 93. So that's an interesting kind of statistic that you want to look at, is how does a batter perform above or below that speed, okay? And what we can do with, you see with Chris Sale up there, you get to see what some of his fastballs are above and below. And one of the things that those data sets come is it categorizes every pitch. So it's not only fastballs, you can look at some changeups, you can look at some sliders, so you can get down to every type of classification pitch that he produces. And actually there's an algorithm based off a neural network that actually automatically classifies those pitches. And I think it's up in the 80s or low 90s success rate. So even in the categorization of the pitches, artificial intelligence is used. Now, the beauty of this is it gave us a lot more features to work with. And I think that is the benefit of having a subject matter expert. I think Paul Zakopoulos mentioned, you know, there's lots of people in your organization. It's not just a data scientist. There's your subject matter expert that can produce more features to you, that can, you know, give more knowledge to you. If we just threw the data set over to Joe, it's highly unlikely he would have ever come up with these features, right? Because the domain expertise wasn't there. He can consume the features we have, but we were able to produce some more. Now, one of the things is what would we have done differently? So this was done in last March. I don't think driverless AI was announced, and I don't think IBM's ICP for data was announced. And these are Dockerized technologies. What it would have made it a lot easier for us. A lot of our time at the start was involved in getting the setup, getting that lab in Texas set up, where if we had these new technologies, which is IBM ICP for data and driverless AI, we would have been able to get up and running much quicker. And that's ultimately kind of where these technologies are going. You can get driverless AI in a Dockerized environment today, and you can get it with an ICP for data, and are much more easier to install. But the beauty of it is it can have technology that can work on-prem or on cloud and allow you to move those workloads seamlessly. So from an architecture standpoint, that's what we would have done differently. So what we also did, and this is where Joe's going to come in, I wanted us to make sure we kind of covered some of the H2O bits, what we did, what the analysis that we did. And at the end, what we're going to show you is a Shiny app, where we're going to show you a couple of players and you can kind of see some of the analysis and the predictions that we did. And the key thing is, remember at the start I said it was generally over 1 year. We went for a 3-year prediction. So to look at a player and look at them 3 years out. So Joe's going to come in now and talk to his bit.
Thank you. So don't go yet. So you probably see me as the selfie guy, so I won't let you down, so I will do it again.
World Series champions.
So occasionally I do data science. So this is one of the projects I did over the last couple of months. So I want to talk about how do we frame this problem as a regression problem, so I can do it with a machine learning platform. So I choose H2O this time, so I can use the AutoML here to build some high quality ensemble. So after I have the features from Ari and the Raymond database. So let me just go through a few things here. So we have the features X here. So these are features that I derived from the Raymond database and those from Ari. So we use that as the features for all the targets. So targets meaning we have different targets for the baseball player performance in different years. So we have the how many home runs he's going to hit, the batting average, and other targets. So we have multiple targets. So we have an ensemble for each of those targets in this project. And after that, we can try to visualize the result. So this is like for one player, this is quizzed out for his performance in the past and then in the futures. So we can see that for the blue area with the data point that we use for training. So any point before 2016, we use that for training. And then for the 2 points here in 16 and 17, we use that for validation, just to have a sense check of the predictions. And then finally, we have the 3 points going forward. So the horizon is 3 years from now. So we have the 18, 19, and 20 for predictions. So these are the predictions that we give it to Ari, and then he can visualize them, and then we can look at them and try to make sense of what's going on with these predictions. And you can also see that there are two kind of predictions. So you can see the green line. The green line is just using the Raymond database features. So they are not as good as the one that I have with the Ari database. So you can see the power when you have some rich data sets. So you can enrich your data sets with external data, put them together to give you a much better model sometimes. But that's not enough to ask Ari to trust me, because we just knew each other for a few months. So I can't say, okay, I'm from H2O, please trust me with my model. So what I can do is to use a Lime package. So Lime is a package that we have in both Python and R, so I'm using the R version this time. So Lime stands for local interpretable model and agnostic explanations. So this gives us some approximate reasoning to explain what's going on from the input, so all the features from Ari and Raymond database, how they lead to the actual predictions at the end. Because if you look at those features from, if you're not a domain expert, you may not make sense of those features because they're like derived attribute from Ari. But Ari himself, he's been working on this for many years. So he can tell whether this model is doing something that he expects from what is the real life situations from different attributes. For example, if you have the fastball curve, the fastball hit rate going up or down, how would that have an impact on the actual performance in the future? So we can tell from this graph using Lime to tell whether this model is doing something that he expects. And it does, so this actually works out very well because this kind of validates his thinking or his expectations of some players in the futures. So then you can use the results from my AutoML, from H2O AutoML, with the predictions for different players in the futures. He had about 5 or 6 players in mind, so they are like the free agents at the time, so he wanted to sign up one of them for his team. So he can go through some players, so, but I cannot just give him the result in numbers. So I created this signing app, which I will show you in a minute. So a signing app that allowed him to navigate different players quickly to see the results of predictions and the Lime explanations. So all I'm going to do now is to show you the actual app quickly, if I have time. Okay. Can you guys see it on the screen? Yeah, so this is the actual app itself. So, for example, we have 2 different results. One is for pitching, if you can see here. So one is for pitching, because there are 2 types of players. So you are in baseball, you either attack or defense. When you do pitching, you try to throw the ball without the ball being hit to outside of the pitch. So you got pitching and batting. So batting is more like attacking. So
the first pitcher up there is Chris Sale,
yep.
pitcher for the Red Sox through the last ball of the World Series. So Red Sox fan, he had to be the first pitcher up there.
Yeah. So what we're saying in this graph is that for the pitching, so some of the metrics they are like the lower the better because they are more like defensive figures. So in this case, we're saying that Chris Sales in the years to come, he will get better and better for pitching.
Yeah, and the reason why there's such a differentiation in the 2 data sets, one is highly aggregated, but remember, now I only gave you a little sample of that pitching data. We have so much more information in that pitching data. You know, we get a couple of 100 pitches, if not near 1,000 pitches a year for Chris Sale, and the amount of features that we have on that basically is why when you couple the layman data with the Ari data, you're getting something a lot more closer to the actual. And that's because of the amount of features we have with the pitching.
Yep. So the next graph you're going to see is this explanation. So we just go through different features, try to make sense of the predictions, and he trusts the model at the end of this graph. So what he can do now, he can go to this drop-down list. He can type in maybe, say, John,
so here's an example, right? Ari gave us 5 pictures,
yep.
which he wanted to analyze. Now,
yep.
luckily, Joe had the database. One of them was John Lackey. He was an unsigned player in March, and I think he may have been. But Ari had an idea that this guy still had something to give. And when you go and you look at the model, it's more or less saying it kind of went with Ari's thinking. Okay, so this kind of solidified in Ari, along with the 4 other pitchers, that of all these guys, they're kind of where he was thinking, and he had all this analysis to kind of back up his thinking. Now, Ari is, a consultant to multiple baseball clubs, so it was great to have that kind of validation.
Yeah. Okay. Thank you, Derek. So that's how he found the player he wants. So let me just summarize it. What happens at the end? So it actually happened. So he found the player. He recommended that to his team, and then he did all the medical check, and after 24 hours, the contract was finalized. So this is a really good example of how you can, if you can understand the business problem first, you have the domain experts to give you some features that you want to use for the business problem, put it into H2O AutoML, give you some quality, high quality ensemble model, give you the predictions, use Lime to explain the result. You can also use Shiny to give you applications to navigate through the result, and that complete the story. So it's like a story, not only about the predictions. It's a whole story to allow Ari to find the player he wants, explain that to his team, and sign the player up. So that, let me just summarize in a time frame like this. So I had the result on the first day. So I got it in an Excel spreadsheet, showed it to Ari, and he said, okay, that's fine. And then next stage, I create a Shiny app for him so he can quickly look at different players. And then he got serious because I didn't know that he was actually using the app at the time to find the player. So I think he was just looking at it like for like a toy demo. And then he actually recommend that player to his team, sign him up with the contract, multi-million contract for 4 years, I guess. And then we have the final date for the talk itself, so we can actually have the real use case to tell the people at IBM Think at the moment. So it was a perfect story to end with the IBM Think conference.
And to back up what everyone is saying, with 80% of being the data, January up until the time frame where Joe got really deep with the training and the modeling was all data prep, all data cleansing, getting all the data into the environment to be consumed. That's what took up a huge amount of time. But obviously when we could give it to you in a decent format, you know, it really got the ball kind of rolling. And just, if any of you read up on the Red Sox, like Alex Cora is like a first-time manager, and his agent is called Coralytics, right? And what he was saying is it's basically analytics, but having the man management side, right? And the ability, and that's why I gave the example earlier on, you might have all the information, but it's how you present it to your audience. You have to know who they are, how they can consume it, and how it can benefit them. And that is why we did the augmented reality. We can't kind of demo to you here now, but we were able to look at pitchers based on their salary and their ERA, and it was a very good visualization tool to kind of see there were some pitchers with very good ERAs that weren't paid as much as some of the better known pitchers like Chris Sale. So again, that became a very good visualization tool.
All right, so thank you for being here.
Thank you, Joe and David. There's one question from the audience.
Sure. Yes, just what's the questions? So did you adjust the model for injuries? So there's no consideration about injuries this time because this is I would say this is version 1 of Moneyball. So maybe if I do it again, maybe I would consider more data like injuries or other things happening in the personal life. So this is version 1. So we didn't consider the injury data.
Somebody had an injured season, we basically gave them a 0.
Okay, so just one more question here. So didn't John Nagli's chart show him he's getting worse in the future? Yes, he's getting a bit worse, but it's kind of stable. So if you consider his age and his salary, that could be like a valuable players for the team.
Or if you think of him pitching 1 or 2 innings at the end of a game. Yeah. Sorry. So this is where you have to look at him. He may not be an opening pitcher. He's not going to pitch maybe 6-7 innings, but he could close out a game. Sometimes pitchers are brought in for like the 9th inning or the 10th inning if it goes into overtime. So you have to have a whole makeup of players. You can't have like 5 starters on your team because they won't be happy. It won't work too well. So whilst yes, he may be getting worse, there's still benefit to him maybe only pitching 1 inning a game.